One of our clients walked over to us and said, "Look, we have a plant which produces tablets, and we want to monitor every single factor: the temperature, the speed at which the fans rotate, the pressure that the coolant is going through, all of this, and we want to monitor this on the floor layout." Now, this is a fairly customized solution. It's got to be tailored for their factory. It's got to take in their data sources. And it wasn't just that. He said, we need advance warning. We want to know beforehand if the tablet's going to turn out bad or not. So, which means there's a certain amount of custom prediction as well that's involved here. This is available at the URL gramner.com/process monitor. And this hosts four views. First, that we'll talk about is literally how the plant operates. There's a feed coming in from solvents, which has material A and material B, and that goes into a reactor. This reactor's temperature is being monitored live. When I say live, we talk about how long the feed has spent in the system. Of course, this is an accelerated live view, so we've already passed 3 minutes in the span of a lot less than 3 minutes. But it's showing a simulation, an accelerated simulation of the flow going in now into the crystallizer, where its current cooling temperature is 66 degrees, and the average cooling temperature is also 66 degrees, and the fan is spinning at 12 revolutions per minute. And then it's moved on to the filter, which is currently being processed, and then into the slurry tank, and then all the way down right to where the tablets separated into fine or coarse powder. One of the things that this system does is also predicts whether the result is going to be fine powder, which is good, or coarse powder. The trouble with coarse powder is that it needs to be ground once again. It doesn't work well for tablets. So based on the data that's coming in, this model is predicting that it's going to be coarse powder now, and the result is bad. But after a while, it corrects itself because the temperature has gone up to a comfortable point, and now the prediction is that it is going to be fine powder, which means that the operator has the option of correcting the result. If it's coarse powder, then the operator can increase the time that it spends in the system until it gets to fine powder, effectively offering something like a real-time alert. But while people may want to monitor it this way, not everyone wants to see the entire flow. They just want to be alerted on their mobile. So there is a mobile view as well, which you see a simulation of here, where it just tells the user that the current batch is meant to be good. And if at any point it turns bad, then they get an alert on their mobile and they can take corrective action then and there. The third possibility is a simulation. Now, what if I could actually increase the reactor temperature to maybe 125% of what it is? Will that produce a good batch and will it stay good? What if I end up reducing the crystallizer cooling rate to as low as 50% of what it was? Will that end up with a batch that consistently stays good, or is it going to lead to a worse batch? Allowing people to take one batch and then doing a what if. Can I change one of the parameters and see what would have happened if we had a different kind of a control that we ran it through? And finally, rather than having to tweak these one by one and waiting for the result to see if it's going to be good or bad, a full-fledged predictor end to end that says, if I have a certain reactor temperature and a reaction time and a crystallizer cooling rate, is this going to give me a good batch or is this going to be a bad batch? Turns out that the current parameters are bad. But if I take the temperature all the way up to, let's say, around 86, still bad. What about 80? Keep reducing it. So changing the temperature, there seems to be a sweet spot around 81 degrees, 82 degrees. But then at around 82.7, it starts turning bad again. So we have a narrow band where we need to keep the temperature for this to work. Similarly, for that particular temperature, there is a reaction, there is a sweet spot for the reaction time, which is fairly minimal. If we let it go for longer than this, then it's not going to be a good batch. So this kind of simulator also allows them to play with what if situations and figure out how they should configure the plant. This is the output. And this was what was built in 3 days using components from Gramix.